Hi, my name is Lauren Webb, and in this video I will be discussing charges, specifically charge tapes for Physics 2212 Lab 1. In this video, I will be giving a brief introduction to the experiment, including the purpose, assumptions made, and the main results. Then I will detail the data I collected and observations I made and answer some key conceptual questions to help us better understand what the experiment is trying to teach us about physics. The purpose of this lab was to help us better understand how objects interact with each other and how neutral objects that we encounter every day in life react to a charge. We will be observing these interactions and collecting data to calculate the magnitude of the electrical force, the charge of tapes, number of excess electrons, the ratio of electrons to atoms, and more. The fundamental physics principles of this lab are Coulomb's law and the momentum principle. Coulomb's law helps us to calculate the vector electric field of a charged object, and the momentum principle explains how certain forces work on objects such as gravity and normal force. The results of this lab include that the U-tapes were positively charged with a calculated magnitude of about 1.49 times 10 to the negative 8 coulombs, and that there were about 9.33 times 10 to the power of 10 electrons on the tape. Before we detail these calculations, let's go over the assumptions we made for the experiment. First thing is that we assume that there is no air resistance. Second is that we treat the tape as a point charge, and furthermore, that this charge is at the center of the tape. And number 3 is that each U-tape has the same charge and that is evenly distributed among the tape. Here are the observations that I made during my experiment. The U-tape in my hand were attracted to each other. The two U-tapes had a strong repulsion between each other, which I predicted because they would be of the same charge. The U-tape and book were attracted to each other, and the U-tape and negatively charged pen were strongly attracted to each other. Based off of this, we can conclude that the U-tapes are positively charged since they were strongly attracted to the negatively charged pen. On the screen is the data that I collected from the lab, such as the length of the tape, width of the tape, the distance between the floating tape, and the mass of the tape. Using the mass, we can calculate the gravitational force on the tape and know that is equal to the opposite of the electric field, because if the tape is suspended in the air and not moving, we can use the momentum principle to justify this assumption. With the electrical force, we can then calculate the charge by using Coulomb's law, and we get that the charge is about 1.49 times 10 to the negative 8th coulombs. Using the data that we collected on the last slide, we can find the number of electrons on the tape by taking the charge of the tape and dividing it by the charge of an electron. By doing this, we get that there are about 9.34 times 10 to the power of 10th excess electrons on the tape. Then, by using the area of the tape and the atom length, we can calculate that there are about 4 times 10 to the 17th atoms on the tape. We can then use the number of electrons to atoms to calculate a ratio of about 2.33 times 10 to the negative 7th electrons per singular atom on the tape. Shown is my computational model and the code that I used in order to get the visual shown on the screen. In my code, I performed all of the calculations that were previously stated and used the program in order to visually depict that the gravitational and electric force on the charged tape are in fact equal and opposite. I then used the code to also give me the values of the charge, number of electrons, number of atoms, and the ratio of electrons to atoms as seen on the screen. Now to answer some conceptual questions about the lab. Electrons are negatively charged and protons are positively charged. What if the signs of their charges were reversed, meaning if electrons were positive and protons were negative? What would change about the observations you made with your tapes and other charged objects? The direction of their electric fields would flip oppositely, since the signs of the electrons and protons are flipping. Also, the signs of the calculations would be opposite. However, the objects behave the same way since the magnitude of the charge will remain the same along with the interactions that are held. The next question is, why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? The more that your hand comes in contact with the tapes, the more that the charge transfers from the tape to your hand, and same with a different neutral object. This is why it is important to avoid touching it with your hand or other objects as much as possible. To wrap up, we can make some conclusions from this lab. Objects with opposite charges attract strongly, like the negatively charged pen and the positively charged U-tape. Objects with similar charges repel each other, like the two U-tapes that had the same charge. The gravitational force is equal to the electric force because there is no momentum or other forces acting on the tape. The magnitude of the charge on the tape, according to the computational model, is 1.49 times 10 to the negative 8th coulombs. This can help us find the number of electrons on the tape by using Coulomb's law to get 9.33 times 10 to the power of 10th electrons. And with that, thank you for watching, and I'll see you next time for Lab 2.